Hello everyone, welcome back. This is lesson number 8, part 2 for Calculus AB, where we're taking derivatives of trig functions. As you guys see on your screen right now, these are 6 trig functions and their derivatives. In the first video, we talked about how to find the derivative of the sine function, the cosine function, and the tangent function. So we actually didn't do any real examples in the first part of the video, so let's actually get to some now. So for these first 6 examples, you guys can see it says find the derivative of the following function involving trigonometry. Be aware of when you might need to use the product or the quotient rule. So the first thing I want you guys to notice is examples number 1, 2, and 3, that all of the functions have a constant and then a trig function, right? Constant trig function. And then we have 2 sets of constants and trig functions. So what I want to just say really quickly about this is that technically you have a function times another function. Right? You have a function times another function, which means that you have to use the product rule, right? But I will show you guys, we're going to do number 1 using the product rule, and then we're going to kind of get an idea, a general idea of what you can easily do to solve these problems. So let's go ahead and get started. So if I use the product rule for this problem, I'm going to first of all write down my first function, which is 2, and I'm going to multiply by the derivative of my sine function, which we now learn is going to be cosine of x. And then I'm going to go plus for product. And then I'm going to go ahead and write down my second function, which is going to be sine. And I'm going to multiply by the derivative of the first function, which again is a constant, so it's going to be 0. So it's the first times the derivative of the second plus the second times the derivative of the first. But I want you guys to notice that this second one, the second term, when we take the derivative of a constant, it's always going to be 0, which means that we never have to do this part. So if we look at the derivative where there's a constant, then there's a rule, a derivative rule here that says if we do this, we leave the constant alone and then we just take the derivative of the actual trig function. So the derivative of 2 sine of x is just 2 cosine of x. It's just that simple. So if we look at example number 2, I want y equals negative 3 cosine of x. Well, the derivative of this, I'm going to go ahead and leave negative 3 alone, and then I'm going to multiply by the derivative of positive cosine, which is going to give me negative sine of x. So this derivative is going to be equal to 3 sine of x. Now I just want to say something very carefully here. We're assuming that it's just a trig function. There's nothing squared or anything else in it. It's just a trig function. Sine of x, cosine of x, cosine of x, sine of x. Okay? Just a trig function. So for example number 3, hopefully you guys are getting this pretty well now, the derivative of this one will be just 5, then times the derivative of cosine. Well, the derivative of cosine again is negative sine. And then I can then do plus, and I'll take the derivative of this term. And so it's going to be 4 times the derivative of sine, which is going to be cosine of x. So our answer is just going to be negative 5 sine of x plus 4 cosine of x. So those are pretty basic problems. So whenever you have a function that has some number a and then a trig function, so let's just use tangent of x. So if some number times a trig function, its derivative will be that number times the derivative of that trig function. And that's all that we have to do. So 1, 2, and 3, pretty awesome stuff. And you can use the product rule for it, but you don't need to, because again, that constant is going to always make that second term go away because the derivative of the constant is 0. So let's look at these next 3 examples. So let's actually look at them, and now I got x squared and I've got sine of x. So this is where I have to use the product rule, right? I've got a function that's x squared. I got another function that's sine x. I am going to multiply them together. That's what my function is telling me to do. So then in order to find this derivative, I have to use the product rule. I have to use it in this particular one. There's no way of getting around it. So let's actually use the product rule. So again, we're going to do y prime. So it's going to be the first. So I'm going to go ahead and write down x squared. And I'm going to multiply that by the derivative of sine. Well, the derivative of sine is cosine of x. And then I'm going to go plus, and then I'm going to take and write down the second one, which is just sine of x. And I'm going to multiply by the derivative of my first. So it's going to be the first times the derivative of the second plus the second times the derivative of the first. And the only thing, and this is a legit answer, by the way, this is totally legit, but you can say that the only thing else I could pull out of this is an x. So we can go ahead and pull out an x, and we get our function like this. And this is a legit answer for this problem. Okay? So that's example number 4. So a good example of when you absolutely have to use the product rule. Well, let's go to an example where you have to use the quotient rule. There is no way of getting out of this one. So we have the function x divided by the sign, right? So we have to use the quotient rule for this particular problem. And I'm so sorry that that looks absolutely horrible for the quotient rule. So let me go ahead. Okay, so it's not better, but it's written a little bit better for us now. So, all right, so let's go ahead and find the derivative of this function using the quotient rule. So y prime is equal to, well, again, we have our denominator, so it's low, and then d high, right? So then we have to derive the top, the numerator, which is just going to be 1. And then the quotient rule has us do our negative. And it's going to be high, d low, right, the derivative of low, all over low, low. So all over low, low. And so it's sine squared x. So now when we simplify this, well, there really isn't anything to simplify. So it's just going to be the sine of x minus x cosine of x all over sine squared of x. A couple things I just want to say here with this problem, and I have students do this all the time, even calculus students, you do not cancel this sign with this right here. You can't do it. Students do that all the time, and I said, okay, guys, well, let me show you this. If I say to you 5 plus 10 over 5, which clearly we know is 3, right? 5 plus 10 is 15. 15 divided by 5 is 3. With students, when they mark these two things out, they're saying, oh, I can just do that. So this answer is going to be 10, or this answer is going to be 11. Clearly not. So please make sure that you do not simplify things out. The other thing that I want to say about this problem that I don't want to see, again, just a silly mistake that students make here, is when they're trying to square this, another acceptable way of showing this squared is just sine of x quantity squared. But I do see students do this, and that's clearly wrong, right? That's wrong. It's the sine of x squared. So just be careful when you're doing this that you write out sine x quantity squared or sine squared x. Okay? So these are just two random things that I just thought of that I want to show you guys from what I've seen students make mistakes on. Okay? So let's look at example number 6. So example number 6, I love this one a lot. We have to use the product rule again, right? Because we have two functions being multiplied together. So I want you guys to get used to that, right? Two functions being multiplied together. I have to use the product rule. And so let's do it. So again, it's going to be the first. And I'm going to multiply by the derivative of the second. So the derivative of cosine is going to be negative sine of x. And then plus the second times the derivative of the first. And the derivative of sine is going to be cosine of x. And so what do I have here is I've got negative sine squared x plus cosine squared x. So I can rewrite this as cosine squared x minus sine squared x. And that is a legit answer, but let's say you take a multiple choice question and you get this answer, and this is none of the answers are what you see matches what's right here. This is not 1, ladies and gentlemen. This is not 1. So hopefully you know before I'm about to tell you what else this is. So if you said in your paper or wrote on your paper that it's the double angle for cosine of 2x, you are also correct. So I just want you guys to know that with the identities here, you have to realize that this is equal to this. This again is a legit answer, but maybe if you do this problem, you may see that this is actually the answer that you get. All right. So those are our very first 6 examples. We're going to do a couple more challenging questions. Notice all of these were just sine and cosine, so let's kind of up the rigor a little bit and do what we can do for the rest of them. Okay, so we went ahead and we want to find the first derivative of these questions, right? So we just want to find the first derivative of these functions. And so we added a couple more problems here where we have not sine and cosine. We're actually doing different ones. So for question 14, this is very similar to what I just did with examples 1, 2, and 3. Finding this derivative is just a constant times a trig function. So this derivative is going to be 3, And so one of the things I should have been saying earlier is that notice that every time I found the derivative of a cosine, I made it negative sign. So I said this in the very first video, that anytime you take the derivative of a trig function that begins with a c, we're going to change its sign. So I'm going to go ahead and put a negative here because we're going to make it a -3. And then just knowing the derivative of cosecant is cosecant x cotangent x. All right, and that's one that you should probably memorize, or you can derive it by finding the derivative of 1 over sine, the way we did the tangent one in the first video, and that way you'll figure out that that's what this is. And then it's going to be -4, and then derivative of sine is just going to be cosine of x. So again, this is a pretty standard one. We keep the sign because the derivative of sine keeps the sign. It's going to be -4 cosine of x. And that's it. That's all you do for this question. There's no trying to simplify. There's no trying to make cotangent cosine over sine and just trying to worry about stuff. We're good with this problem. For question number 15, this one is, again, a product rule question. So we're going to call this our product rule question. So for this problem, we're going to do y, and then the more you practice, the better you're going to get at it. So it's going to be the first times the derivative of the second. Well, the derivative of secant is just secant x tangent x. And I said earlier in video 1 that if you guys look at secant, if you know secant, secant tangent, then cosecant is the reciprocal of these. It's going to be cosecant cotangent, but again, we changed the sign. So they're very similar. That's why we put them here for you. So it's going to be the first times the derivative of the second plus the second, right? The second derivative, then times the derivative of the first, which is going to be 1. And so another thing that we can look at here, and again, that's a legit answer, but we can pull out a secant, right? We can pull out a secant, and we're going to get x tangent of x plus 1, okay? Plus 1. So that's that problem. And number 16. So this is going to be the crazy one, and I'm going to simplify it all because it ends up being a very beautiful problem. So this is where we're going to finish up our video for this one. It says y equals cosine of x over 1 minus sine of x, and let's do it. Let's do it. So we're going to have to use the quotient rule. So we're going to just actually start here with our good old quotient rule problem. And so y prime is going to be equal to, I'll go ahead and draw myself a nice little line here. So it's going to be your denominator. Make sure we keep our parentheses. All right, our denominator. And then we're going to multiply by the derivative of our numerator. Well, the derivative of our numerator is going to be negative sine of x. Okay, negative sine of x. Again, begins with a c, change the sign. So negative sine of x minus our numerator, and then times the derivative of our denominator. Well, the derivative of 1 is 0. And so derivative of negative sine is actually going to be negative cosine. Okay, negative cosine. And then it's going to be all over 1 minus sine squared x. And again, put that in parentheses, so it's the whole quantity squared. So let's start simplifying a little bit. Let's show you what really awesome thing happens with this problem. So this is negative sine of x being multiplied to these things right here. So I'm going to go ahead and do that. I'm going to do negative sine x times 1. It's going to give us negative sine x. And I've got a negative sine x times a negative sine x, which is going to be a plus sine squared x. And then I've got a negative cosine of x times a negative cosine of x, which gives me a cosine x squared, positive cosine x squared. And then we're going to go ahead and do 1 minus sine x squared. Okay? Now, when we're going to continue on with this problem, again, all I did was the quotient rule in green, and then I just started simplifying my numerator in brown. So now we have this wonderful thing. We have this as an identity. So cosine squared x plus sine squared x is actually equal to 1. It doesn't go away. It's actually equal to 1. So what I'm going to do in the next step is I'm going to move the 1 over here, and I'm going to go ahead and say it's 1 minus sine x in the numerator, and then 1 minus sine x squared in the denominator. So far, so good. Hopefully, hopefully, hopefully. And then you guys are going to say, oh, look at that. This cancels with this. And so I can finally say in this problem that y prime is just 1 over 1 minus sine x. And yes, you can expect to see something something like this. I mean, it's a good question for us to do. I mean, it's not the best multiple choice question that requires a lot of work, but it's a good one for us to see the work for. to see what you guys can do with that problem. Okay, so again, with the green, I went ahead and used the quotient rule. So denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over my denominator squared. I then simplified my numerator. Here it left my denominator alone. I found the identity that sine squared plus cosine squared is equal to 1. And then I went ahead and said, okay, this is negative sine of x plus 1, which is the same thing as 1 minus sine of x. I canceled them out, and I'm left with 1 over 1 plus 1 minus 1 over 1 minus sine x. So sweet, sweet, sweet question. So ladies and gentlemen, that is video number 2. In video number 3, we're going to talk about secant derivatives for trig functions and do some of those. So come back, and I'll see you guys in the third video.